Hello everyone, it's Jen from Old Tinker's Studio. In this tutorial, we will be learning how to make a procedural leather texture in Blender 2.9 and how to use it on a model. This tutorial is using Blender 2.9, but you can also follow along with Blender 2.83. So let's get on with the tutorial. Let's first make a very simple model of a handle, something that could be used for a fantasy warhammer. We will be using this model later in the tutorial. Delete the default cube and add a cylinder with 32 vertices and a triangle fan cap fill. And scale the cylinder to the desired size. Then apply the scale using Ctrl A. Right-click to open the Object Context menu and choose Shade Smooth. Rename the object to Handle. Tab into Edit Mode and add 2 horizontal loop cuts to delineate where the leather texture will be applied. Select the faces between the horizontal loops and separate them from the rest of the cylinder using P. Then rename the object to Leather. Hide the handle. Tab into Object Mode. Add a plane. This will become the leather strap. Tab into Edit Mode and rotate the plane around the x-axis 90 degrees. Then scale the plane down to a smaller size and move it to the right and bottom of the leather object. Select the right side vertices and delete them. Rename the object Strap. Select the strap and add a screw modifier. Using the screw option, begin making the strap rotate around the leather object. You can scale and move the original 2 vertices for more control over the look of the leather strap. Using iterations allows you to choose the number of times the strap will go around the leather object. Now add a shrink wrap modifier. This will allow us to attach the strap to the leather model. For the target, choose leather. Now add a solidify modifier and change the offset to 1 so the thickness will be on the outside of the leather object. And then change the thickness setting to your desired size. Now hide the leather and strap models. We will come back to them later. Let's now work on the actual leather texture. Tab into Object Mode, add a plane, and rotate it around the x-axis 90 degrees. Under the Shading workspace, add a new texture and name it Leather. Add a Voronoi Texture node. This type of node is used to evaluate whirly noise, which is a type of noise function that randomly distributes points in space, organized as grid cells to create procedural textures. Connect the distance output of the Voronoi Texture node to the base color input of the BSDF shader. Now we can see the cells produced by the Voronoi texture. The distance output is used to calculate the value of the cells. The color output will show you random colors so you can easily see the cells. The position output is the position of the feature point. The dimensions option is the dimensions of the space to evaluate the noise. We're going to change this to 2D since Z-space is ignored. The distance metric determines the distance between 2 points. The feature option computes and returns the distance to other points. Change this to distance to edge, so it'll compute and return the distance to the edges of the cells. The vector input evaluates the noise. The scale input scales the noise, and randomness input is the randomness of the noise. So duplicate the Voronoi Texture node, add a Mix RGB node, the Mix RGB node mixes images, or noise in our case. The color output is the output of the mixing of the two color inputs. Connect the color output of the Mix RGB node to the base color of the principal BSDF shader. The Blend Modes options allows you to select various means of combining the color inputs. We will use Overlay to blend the two Voronoi texture nodes. The Clamp option determines the output value. The Factor input controls the amount of influence each node exerts on the output image. We will change this to 0.8 to mix the two Voronoi textures. The Color 1 input is the input for the texture node. Connect the distance of the first Voronoi texture node to the color 1 of the Mix RGB node. The color 2 input is the second input for the texture node. Connect the distance of the second Voronoi texture node to the color 2 of the Mix RGB node. Add a value node. A value node is used to input numerical values to other nodes in the trees. Change the value of the value code to 5. This will maintain the scale of the cells. Smaller values mean larger cells. Connect the value output of the value node to the scale input of both Voronoi texture nodes. Add a math node between the value node and the second Voronoi texture node. A math node performs math operations. The value output is the numerical value output. The operation option is the mathematical operator applied to the input values. Change this to multiply, as this will multiply the input values. The clamp option determines the output value. The value input is the value used for the trigonomic function. And we're going to change the value to 1.5. Smaller numbers mean larger cells. Add a texture coordinate node. The texture coordinate node is used for the coordinates of textures. The generated output generates texture coordinates from the vertex positions of the mesh. The normal output uses object space normal for texture coordinates. The UV output uses the UV map for texture coordinates. This is what we will be using when we apply the texture to the model. The object output uses the object as the source for the coordinates. This is what we'll be using for the texture. So we will need to connect the object output to the vector input of both Voronoi texture nodes. The camera output uses camera space for texture coordinates. The window output uses shading points for texture coordinates. The reflection output uses the direction of the reflection vector as a texture coordinate. The object option is used for object space coordinates. The from instancer option is used when the object is generated by instancing from vertices or faces. Add a noise texture node. The noise texture node evaluates the fractal Perlin noise, which is a type of gradient noise, at the input texture coordinates. The factor output is the value of the fractal noise. The color output will show you random colors so you can easily see the fractal noise. The dimensions options is the dimensions of the space to evaluate the noise. The vector input evaluates the noise and is used to evaluate the noise input. The scale input scales the base noise. We're going to change the scale to 1. The detail input is the number of noise octaves. Change the detail to 5. The roughness input blends between a smooth noise pattern and a rougher noise pattern. Change the roughness to 1. And the distortion input is the amount of distortion. We'll change the distortion to 5. Add a second mix RGB node. Connect the factor output of the noise texture node to the color 2 input of the second mix RGB node. Connect the object output of the texture coordinate node to the color 1 input of the second mix RGB node. Change the blend node of the mix RGB node to add. And connect the color output of the second mix RGB node to the vector input of the second Voronoi texture node. Add a color ramp node. And place it between the first mix RGB and the principal BSDF shader. A color ramp node is used for mapping values to colors using a gradient. The color output will show you the colors of the gradient. The alpha output is used to control transparency. The color ramp widget allows you to add and subtract color stops, choose options from Specials menu, change the color modes, change the interpolation options, change and move colors via the color stops, choose the active color stop, change positions of the color stops, and change colors via the color picker. The factor input is used as an index for the color ramp. Change the white color stop to a darker brown. I'm using the hex code of 624A2E. Then change the black color stop to a lighter brown. I'm using the hex code of 8B6941. Now move the darker brown color stop towards the left to expose more of the lighter brown color. Now it is time to apply the material to the model. Hide the plane and unhide the sections of the model. Choose the strap object, and from the drop-down menu, choose the leather texture. Change the texture coordinate node outputs from object to UV. We'll just use the UVs provided by Blender for this tutorial. Then change the value of the value node to get the desired look. Higher numbers mean a smaller texture. Add a bump node. The bump node generates a normal from a height texture. The normal output is the normal vector output. The invert option inverts the bump mapping. The strength input determines the strength of the bump mapping. The distance input is a multiplier for the height value. The height input determines the amount of offset from the surface. The normal input is the normal vector input. Connect the color output of the first mix RGB to the height input of the bump node. Connect the normal output of the normal node to the normal input of the principal BSDF shader. Then change the strength and distance to achieve your desired look. If you have a request for a tutorial or a question about Blender, feel free to leave a comment. If you're interested in learning more about 3D art and animation, don't forget to subscribe and turn on the notification bell. Thanks for watching.